Hey guys, this is Coach Lowe, and we're going to talk a little bit about parallelograms. So this is 6-2, geometry, parallelograms. All right, so in your notebook, you can go to the green flip tabs, and your first flip tab is a parallelogram. And so go ahead and open that up, and you should have two spaces when you open that up, a rectangle on the top and a rectangle at the bottom. So at the top one, let's write some things down, some characteristics about parallelograms. A parallelogram is a quadrilateral, it's four-sided, and opposite sides are parallel. So hence the name parallelogram. So opposite sides are parallel. So on the picture, on the front of this, if you did not mark, so let's close the flat back. When you drew the picture of this parallelogram, if you did not mark opposite sides parallel to each other, then you need to mark that real quick. All right, so do that and then open that flap back up. So we're on the parallelogram flap. If a quadrilateral is a parallelogram, then opposite sides are congruent. So to be a parallelogram, opposite sides are congruent. So in addition to opposite sides being parallel, opposite sides are congruent. So if you want to mark those opposite sides congruent, you might use a different color so that it will show up here. See if I can get it to work. All right. So opposite sides are equal to each other. They're congruent. So we've marked that with red and blue. All right. The next one, opposite angles are congruent. Opposite angles are congruent. All right, so let's go ahead and mark those. So this angle would be congruent to that one. So we're going opposite corners here. This angle congruent to that angle. All right, consecutive angles are supplementary. Consecutive angles are supplementary. So we know that supplementary means they add to be 180. So if you need to stop this and write, could you just go right ahead? So I'm going to go ahead and name this quadrilateral, which is a parallelogram. And if you want to write like opposite sides are congruent, so that means AD is congruent to BC and AB is congruent to DC. And then opposite angles, angle A is congruent to angle C and angle B is congruent to angle D. Consecutive angles. So as I roll around this thing, if you want to go clockwise or counterclockwise, it doesn't matter. And it also doesn't matter where you start. A and B will add together to be 180. So the measure of angle A plus the measure of angle B is equal to 180 degrees. That's definition of supplementary angles. Supplementary angles add to be 180. So you can go ahead and roll all the way around this. The measure of angle B plus the measure of angle C would add to be 180. Measure of angle C plus the measure of angle D, 180. Measure of angle D plus the measure of angle A. So you could write those all out if you wish. All right. And then the last one, if a parallelogram has one right angle, then it has four right angles. Which puts it in a special category. It would either be a square or a rectangle, right? Because we know that those shapes have four right angles. Those quadrilaterals have four right angles. So squares and rectangles are special types of parallelograms. And we'll get to that as we move through this chapter. All right, so let's take what we know here and actually let me add two more things real quick and then we'll work an example. Diagonals bisect each other. We know what bisect means. It's going to cut it into two equal pieces. So the diagonals bisect each other. So draw a little bit better picture here since that one's a little cluttered. The diagonals, so as I go across, are going to bisect each other. So this piece is equal to this piece, and this one is equal to that one. All right. the diagonals separate the quadrilateral into two congruent triangles. So they separate the quadrilateral or the parallelogram into two congruent triangles. All right, so that means here's a diagonal, and it would go with this triangle. And this diagonal would go with that triangle. All right. So if I just use this diagonal, the first blue one, you can see the two congruent triangles here. And you can go the other way like I did on the last one. If you use this diagonal, we have two triangles here. So there's two different ways that you could do it. I hope you saw that and that wasn't confusing the first time. So whichever diagonal you choose, it's going to cut the parallelogram into two congruent triangles. So there's one and there's two. Or if you decide to go the other direction with it, with the red, we could go with this triangle and this one. All right, so I have two congruent triangles. I have opposite angles that are congruent, reflexive property, opposite sides are congruent. So we can use all kinds of, we could use side, 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 we could use side, angle, side, all kinds of fun stuff with those two triangles. All right, so let me give you an example. Now this will go in your notes so you can get off of the, move away from the flip chart and go to the next page after your 6-1 notes, and let's start 6-2 notes. All right, so if you want to put a little note to refer to your flip chart here for properties, I don't know if you want to call it flip, flap, whatever. Put yourself a little note there. All right, then let's sketch this figure. And we're going to work about 2 problems. And then we will work some more in class together. All right, so there's my parallelogram. And there are my diagonals. This is 2t. This side is 4r. This part of the diagonal is 7s plus 3. This is w. By the way, remember how we name parallelograms or quadrilaterals? This would be quadrilateral, and you could start wherever you want and go clockwise or counterclockwise. So I like w, x, y, z to name that. 40 degrees for this angle, 18 degrees for this one, 8s here, 18 here. All right, so here are my 3 questions for you. Find A, B, and C. So for A, we want to find the value of R. For B, we want to find the value of S. And for C, we want to find the value of T. So if you'd like to stop the video, look at your properties, and see if you can figure out how to find these, and then come back and we'll talk. All right, so now that you've tried that, let's find R here. 4R is equal to 18 because opposite sides of a parallelogram are congruent to each other. So for A, 4r equals 18. Divide by 4 on both sides. 18 fourths is the same as 9 halves, or 4.5 or 4.5. So r is 4.5. All right, let's find s. So we have this piece that is 7s plus 3, and we have this piece that is 8s. All right, we know that diagonals of parallelograms bisect each other, which means this diagonal WY cut ZX in 2 equal pieces. So for B, we know that 8s has to be the same measure, has to be equal to 7s plus 3. So solving this single or two-step equation, single step now, is we end up with s equals 3. So pretty quick on that one. All right, and then the last thing, we're supposed to find t. So we see here that this angle 2t is equal to y here, and we can use alternate interior angles on this one. We have lines here and a little oh no, we can't use that. Too bad, so sad. All right, but we do know that these angles are going to be congruent to each other because remember, these two triangles are congruent, right? And so we can use that. We can pick out this triangle right here off of diagonal WY and this triangle right here. Triangles are congruent to each other. These angles are congruent, so we can set those equal. Darn it, I thought I was going to get to use alternate interior there, pull something from first semester. Stink. Oh well. All right, so t equals 9 on that, and so we are finished with that problem. Yay. Yay us. All right, last one, and then I will let you go. All right, so we want to find the coordinates of the intersection of the diagonals of parallelogram MNPR. All right, so find the intersection of the diagonals of a parallelogram. So here's my parallelogram, here's my diagonals. We're trying to find out that point right there where they meet. All right, so where M is negative 3, 0, N is negative 1, 3, P is 5, 4, and R is 3, 1. All right, so let's just sketch this real quick. So negative 3, 0, negative 1, 3, 5, 4, and 3, 1. All right, so I have M, N, P, and R. This will be a wonderful sketch because it's so to scale here. All right, that's terrible, but we get the point, hopefully. Yeesh. Graph paper, great here. Let's see if I can get that to move just a little bit. Will it move? Let me move it. No, it will not. Awesome sauce. See if I can do a little bit better job here. All right, so negative 3, 0, negative 1, 3, 5, 4, and 3, 1. A little bit. All right, so we want the diagonals of this parallelogram. We want the intersection of those. So there are my diagonals. I want this intersection point. Remember, these diagonals bisect each other. So if I can find the middle of this and the middle of this or, it's the same point, I will have where they cross, where they intersect. All right, so this is M, N, P, and R. So if I can find the midpoint of NR, or you can use MP, it doesn't matter, then I'm in good shape. All right, so let's try NR. All right, so I want the midpoint of NR, midpoint formula. Add my x's together and divide by 2, add my y's together and divide by 2, and bam, we've got the midpoint. All right, so x coordinate for n is negative 1. Y coordinate for n is 3. So I pluck the x coordinate, put it here for n, and the y coordinate and put it here for n as well. All right, now we're moving to r. So here's my x coordinate, so plus 3, and here's my y coordinate, so plus 1. All right, so I add my x coordinates together, add my y coordinates together. So negative 1 plus 3, then I'm going to divide that by 2. 3 plus 1, which is 4, I'm going to divide that by 2. All right, so negative 1 plus 3 is 2 divided by 2, and then 4 divided by 2. So I get 1, 2 for the midpoint. Right, and that's it. All right, so we will discuss this a little bit more when I see you again. This is Coach Lowe, and I'm out.